My name is P. Jahnavi. I am studying BTech second year of ECE branch. Now I am discussing about the subject probability theory and stochastic process. In this, I am discussing about the subject topic properties of power spectrum density. This is the first property as xx of omega greater than or equal to 0. Proof. This is the proof from the definition. The expected value of a non-negative function means e of mod xt of omega whole square is always non-negative. Means hence sxx of omega greater than or equal to 0. Next property, the power spectral density at 0 frequency is equal to the area under the curve, the autocorrelation Rx6 of tau. Sx6 of 0 means autocorrelation function equal to integral minus infinity to infinity Rx6 of tau deta. This is the proof. From the definition, we know that Sx6 of omega equal to integral minus infinity to infinity Rx6 of tau e power minus j omega t tau deta. At omega equal to 0, at means at 0 frequency, Sx of here omega we replace it 0 equal to integral minus infinity to infinity Rx of tau deta, hence proved. Next, third property, the power density spectrum of a real process x of t is an even function. Means that is Sx of minus omega equal to Sx of omega x of t is real. This is the proof. Consider WSS real process x of t. WSS means Weissen's stationary, means time do not change with respect to time. Then Sx of omega equal to integral minus infinity to infinity Rx of tau e power minus j omega tau deta. This is the autocorrelation function Sx of omega. We replace it with minus Sx of minus omega equal to integral minus infinity to infinity Rx of tau e power j omega tau deta. Substitute tau equal to minus tau, then Sx of minus omega equal to integral minus infinity to infinity Rx of minus tau e power minus j omega t deta. Since x of t is real, from the properties of autocorrelation, Rx of minus tau equal to Rx of tau, Sx of minus omega equal to integral minus infinity to infinity Rx of tau e power minus j omega tau deta. Here the even function Sx of minus omega equal to Sx of omega. Next, this is the fourth property. Sx of omega is always a real function. Proof. We know that Sx of omega equal to limit t tends to infinity e of mod xt of omega mod square by 2t. Since the function xt of omega whole square is a real function, Sx of omega is always real. If Sx of omega is PSD of the Weissen's stationary random process x of t, then 1 by 2 pi integral minus infinity to infinity Sx of omega d omega equal to a of E of x square of t equal to Rx of 0 at the time average of the mean square value of WSS random process equals the area under the curve of the power spectral density. Rx of tau equal to E of x of t plus tau x of t. The expectation of the autocorrelation function that equal to 1 by 2 pi integral minus infinity to infinity as x of omega e power j omega t d tau d omega. Now at tau equal to 0, Rx of 0 equal to E of x square of t equal to 1 by 2 pi integral minus infinity to infinity x of omega d omega. Area under the curve of x of omega. If x of t is a WSS random process with PSD x of omega, then the PSD of the derivative of x of t is equal to omega square times the PSD sx of omega. Means sx of omega is the derivative of x of t, which is equal to omega square times the PSD of sx of omega, that is sx of omega equal to omega square sx of omega. Sx of omega equal to limit t tends to infinity E of mod xt of omega square by 2t. Xt of omega equal to integral minus t to t x of t e power minus j omega t dt. X conjugate t of omega equal to dx of t xt of omega by dt equal to d by dt of integral minus infinity to infinity xt of e power minus j omega t dt. Integral minus t to t x of t d by dt of dt e power minus j omega t dt, that equal to integral minus t to t x of t of minus j omega e power minus j omega t dt. Minus j omega is take outside and integral minus t to t x of t e power minus j omega t dt. Therefore x conjugate t of omega equal to minus j omega xt of omega. So sx of omega equal to limit t tends to infinity e of mod x conjugate t of omega whole square by 2t. Hence prove. This is the seventh property. The power density spectrum and the time average of the autocorrelation function of a Fourier function of form a Fourier transform pair, means PSD and time average of autocorrelation function forms a Fourier transform pair, that is sx of omega equal to integral minus infinity to infinity Rx of tau e power minus j omega t d tau omega tau d tau, and Rx of tau equal to 1 by 2 pi integral minus infinity to infinity sx of omega e power j omega tau d tau. Next, consider a WSS random process x of t. We know that the time average of the autocorrelation function is a of Rx of t comma t plus tau equal to a of e of x of t plus tau, means expectation of autocorrelation function for a WSS random process a into A of Rxx of t comma t plus tau equal to Rxx of tau. Now the power spectral density is Sxx of omega equal to limit t tends to infinity E of xt of omega whole square by 2t, but we know that xt of omega square equal to xt of omega x star x conjugate of t of omega. Let xt of omega equal to integral minus infinity to minus t to t x of t1 e power minus j omega t1 d1 x conjugate t of omega equal to integral minus t to t xt of e power j omega t dt. Sxx of omega equal to limit t tends to infinity e of 1 by 2t integral minus t to t x of t e power j omega t dt of and minus t to t x of t1 e power minus j omega t1 d1 dt1. Next, Sxx of omega equal to limit t tends to infinity 1 by 2t integral minus t to t integral minus t to t e of x of t1 x of t t of e power minus j omega of t1 minus t dt dt1. We know that e of x of t1 x of t equal to Rxx of t comma t1, that is Sxx of omega equal to limit t tends to infinity 1 by 2t integral minus t to t again integral minus t to t Rxx of t comma t1 of e power minus j omega dt t minus t1 minus t dt1 dt. By taking inverse Fourier transform 1 by 2 pi integral minus infinity to infinity Sxx of omega equal to omega of e power j omega tau t d omega equal to limit t tends to infinity 1 by t integral minus t to t integral minus t to t Rxx of t1 t comma t1 of 1 by 2 pi integral minus infinity to infinity e power j omega t e power minus j omega t1 minus t d omega dt1 dt dt1. Limit t tends to infinity 1 by 2t integral minus t to t minus integral again integral minus t to t Rxx of t comma t1 of 1 by 2 pi integral minus infinity to infinity e power minus j omega of t1 minus t minus tau d omega dt dt1 previous. Thank you.